So we've been working on some pretty easy and one easy, one medium problem so far, and I think we should try a hard one. This looks pretty hard, so let's go for it. We have the sum from n equals 2 to infinity of 1 over ln of n to the power of ln of n. Now, I wouldn't recommend using ratio. Nothing to cancel out. Roots, again, nothing to cancel out. Alternating series test wouldn't also work because there's no negative 1 to the power of n, no alternating series in itself. Integral doesn't look too fun or nice to do, so we can try the comparison test. Now, it's kind of hard to see what you'd compare ln of n to the power of ln of n to, so let's see if we can maybe simplify that or find something that looks similar to it. Okay, so we have ln of n to the power of ln of n. Now, maybe what we can do is find something that looks like ln of n, and maybe substitute it here. So, it's pretty easy. We know that e to the power of ln of n, or at least I hope we do, equals ln of n. So having this, we can just plug it right into there. So then we get e to the ln of n to the power of ln of n. And we can actually interchange these. So let's do that. We got e to the ln of n to the power of ln times ln, to the power of ln of n, sorry. So now, what we should do is, because you don't want to write this there, so let's just say for now that e to the power of ln of n is equal to n. So if e to the power of ln of n is equal to n, then what does that mean? Then that means that ln of n to the power of ln of n is equal to n to the power of ln of n. So we good? Follow me? So we're almost done with this part, actually. So now we have to kind of put I guess you could say a limit on ln of n, because it can't be any number. So if we say that, let's say, so if n approaches infinity, then ln of n must be greater than 2. Okay, so using these two pieces of knowledge, we can now finally do a comparison test. So we compare 1 over our original equation, ln of n to the power of ln of n, to, actually no, this equals 1 over n to the power of ln of n, what we got up here. So then this is less than 1 over n squared. And now we know that 1 over n squared is a p series, which is greater than 1. So if it's greater than 1, means it's convergent. And by the comparison test, if b of n, your chosen function, is convergent and is greater than your original function a of n, then your original function is also convergent. So this is convergent by the comparison test.